Oh, hello again. Nice to see you. Welcome back to another take on Learning Math for the SAT. I'm Mr. Ellis. This time, however, you've got guided notes. You're going to copy down everything that I write in the appropriate section. We're starting off with level 1. So in level 1, you should see this problem right here. Negative 8 plus n equals 23, and we are solving for n. Again, solving for n means you're getting n by itself. Looking at this equation, I have a negative 8 plus n equals 23. My goal is to get rid of that negative 8. So, I'm going to do the opposite of negative 8, which is, well, yeah, that's right, add 8. We're going to add 8 to both sides. What happens when we do this is we're going to combine like terms. This negative 8 will combine with this positive 8. And negative 8 plus 8 gives us, very good, 0. I like it. So negative 8 and 8 is 0. I do not need to write my 0 because 0 plus n is still just n. What we call that is canceling out our negative 8. That being said, we need to simplify the right side. 23 plus 8, do some quick calculations. 8 plus 3 is 11, carry my 1. I got that n is 31. Let's try the second one, very similarly. I have 18 equals n minus 18, and my job is to solve for n or get n alone again. So, this time, I have a minus 18. I need to get rid of my minus 18 by doing what? No, you don't subtract 18. That's wrong. What do we do instead? Yeah, add 18. That's what I like to hear. So we add 18 on both sides. Our 18s will cancel out again, leaving us with n. And on the left side, we add. 8 and 8 makes 16. Carry my 1. 1 plus 1 plus 1 is 3. Now you have these practice problems on the right side of your paper. You have 54 seconds to get these done. Don't let me down, sailor.
Back. Now we're on level 2. Remember, anything I write down, you need to write down. So we have negative p plus 60 equals negative h plus 10,000. In the equation above, h is a constant. If p equals 10 is a solution to the equation, what is the value of h? So they're telling us something and they want us to find this other guy. So our main problem here is that p equals 10. So anywhere I see a p, I can replace it with, good, 10. So I can replace that p, and because it was negative p, my 10 is negative. Plus 60 equals negative h plus 10,000. Now we need to start combining our like terms. On my left side, I have a negative 10 plus 60. Or another way of thinking of it, 60 minus 10. I think to myself, 60 minus 10 is, no, not 70. Good, 50. On my right side, I have a negative h and a 10,000. I can't combine these because one is a variable, one is a number. So I'm just going to bring these guys straight down. Now we start solving for h. Just like in level 1, I have to undo my operations to cancel them out. So the opposite of adding 10,000 is, good, subtracting. 10,000 minus 10,000 gets me, good, 0. So I bring my negative h down, make sure you don't drop that negative. It's one of those common mistakes that we see happening. And now I have 50 minus 10,000. This might look really hard, but as long as you know the trick to subtracting. I'm going to take the bigger number and subtract the smaller number, and then whatever the sign is of my bigger number will be my sign on my answer. So I have 10,000 minus 50. Well, I have a bunch of zeros, so I'm just going to start borrowing. Borrow to make 10, borrow again to make a 9, borrow again to make 9. 0 minus 0 is 0, 10 minus 5 is 5, and then I have 2 9s coming straight down. Okay, so my 50 minus 10,000 is 9,950. I look at the sign up for my bigger number. 10,000 is way bigger than 50, so I have a negative 9,950. Now I need to get rid of my negative on my h. Do we remember how to get rid of that negative? Good, we divide by a negative 1. Remember our common rules. Negative over negative, or negative divided by negative, is a positive number. So negative 9,950 divided by negative 1 will get me a positive. Anything divided by 1 is the same number, so 9,950. Negative h over negative 1, the negative and negative will change to positive. Anything divided by 1 is itself, so we found our answer h. Alright, now on to example 4. We have 4 plus 5m equals 4m plus 1 plus m. And they ask us which of the following best describes the solution set to the equation shown above. So I'm going to rewrite my problems off to the side so I have some work to work with. And now, just like the last equation, I need to start combining any like terms I have. So looking on my left side, I have 4 plus 5m. So I think to myself, can I combine a 4 plus 5m? No, you can't combine them. One has a variable, one does not. These are not like terms. So my left side is as simple as it gets. Now I look on my right side. I have 4m plus 1 plus another m. Do I have any like terms? Good, I do. I have a 4m and an m. And remember, if you don't have a number up there, you have an invisible 1. So now I'm thinking both are positive, so I'm adding. 4 plus 1 is good, 5. So I have 5m plus 1. Now I need to start bringing my like terms that are on opposite sides of the equal sign together. So I have a 5m here and a 5m here. I'm going to send my 5m's from the left to the right. So to undo my addition, good, subtract. I have a negative 5m and then 5 minus 5m. Those will cancel, so I have just my 4 left. Another 5 minus 5m, so that also cancels. And then I have my 1 coming straight down. And now I'm at where I can start looking at my answers to find my answer. I have 4 equals 1. Is that ever possible? Good, it's not possible. There's no way that a 4 is equal to 1. If I have 4 apples, I don't magically have 1 apple at the same time. So now I start looking at my answers. The equation has exactly one solution. It says m is 0. That's not what we got here when we solved. Same thing with b. So I'm down to my last 2. It either has no solutions or infinitely many solutions. I know that it has no solutions because 4 is not 1. So my answer will be C. Now a quick note, what would my answer look like if it was D when I have infinitely many solutions? Well, just like here where it says 4 is not 1, to be infinitely many, I would have to have a number equal to itself. Doesn't matter what the numbers are, they're just equal to themselves. Okay, now you have 4 minutes to try your level 2 practice problems, number 3 and number 4.
Welcome back to level 3. It's getting a little bit harder now, but don't worry, I'll walk through it with you. If negative k plus 78 is equal to 98 minus 20, then what is the value of k? This is a word problem just asking us to solve for k. No big deal, no different than what we've been doing. So let's start. I have negative k plus 78 equal to 98 minus 20. What's different about this problem is I have some simplifying to do first. What that means is I need to take some of the expressions I have and condense them or shrink them into a smaller problem first. So, I see that I cannot combine negative k plus 78 because they are not like terms. However, 98 and 20 are like terms and they're being subtracted. So I'm going to start by subtracting 20 from 98. I'm going to copy my left side. And then I'm going to subtract like I said I was. 98 take away 20. 8 minus 0 is 8. 9 minus 2 is 7. So I get 78. All right, so far so good. Now I need to isolate k. However, I have a positive 78 along with k. What am I going to do to eliminate 78? Very good. Subtract 78, because it's the opposite. We subtract 78 from both sides of the equation, because what we do to one side, we know we do to the other. Our 78s are the exact same on the right side, so they cancel out, as they are on the left side, so they cancel out. Notice on this side, I had nothing else left. So if I canceled it out and left it blank, we'd have nothing. So I put a 0. On the left side, I still have a negative k. Negative k is equal to 0. As stated previously, anytime you have a negative, you can imagine there's a negative 1 right here. Hey, little fella, there you are. To get rid of that negative 1 multiplying k, we need to divide by negative 1. Division is the opposite of multiplication, for sure. Divide both sides by negative 1. K equals, and this is an interesting problem, so I'm going to explain it verbally. If you had 0 cookies, which I do, and I share it with one person, how many cookies do I get? I get nothing. So, 0 divided by any number is 0. We found our k value, we found our solution, we move on. Welcome back. Example 6 on our level 3 is a little bit different, but we'll use some of the ideas from before to answer. Negative 4 plus bx equals 2x plus 3 times the quantity, x plus 1. In the equation shown above, b is a constant. For what value of b does the equation have no solutions? We're interested to know what b is so that this equation would have no answers. Let's start by trying to simplify what we already have. We have negative 4 plus bx is equal to 2x plus 3 times the quantity, x plus 1. We're going to start by simplifying, by making things smaller and more compact so that we can more easily see our answer. On my left side, I have a negative 4 and a bx. I cannot combine these because they are not like terms. So I'm going to ignore the left side for now and move on to the right side. I have 2x plus 3 times the quantity, x plus 1. Anytime I see a number outside of parentheses, it should ring a bell in my head to distribute. Distribute means to give something to everybody in question. In this case, we're giving this 3 to each thing inside of the parentheses through multiplication. Do not add, make sure you multiply 3 times x and 3 times 1. Let's rewrite our work. Negative 4 plus bx equals 2x plus, now we start multiplying. 3 times x is 3x. 3 times 1 is positive 3. All right, now we've gotten rid of our parentheses and I see some like terms that I can combine. Where are they? Good, it's the 2x's on the right side. if you were that specific, which you were because I heard you. So let's copy the left side. Negative 4 plus bx equals, I can combine these into 5x. This 3 was unable to combine with it because it has an x, so it stays out here by itself. You think about what you did, 3. All right. Now, this is where we're going to use an idea that we learned in level 2. If we have 2 values of x on each side, the coefficients matching is going to help us find our best answer. We talked about it. We had a number on the left side not equaling the number on the right side. I believe we had 1 equals 4. This provided us with no solution because 1 will never equal 4. The way that we got to this point was by canceling out our x's. So, if we are looking for a way to have no solutions, we need a way to cancel out our x's. In order for our x's to be the same, to cancel out, they need to be the same. And I'll show you how that works. If this b value was a 5, for instance, let's plug in 5, just check our work. I'll even do that in a different color so you're not confused. Red. Hope this shows up. We're just going to plug in 5. That was one of our options. If I try to get all of my variables on one side and all of my numbers on the other, I'm going to move my 5x over by subtracting 5x. What I do to one side, I do to the other. And what we should notice is that on the left side, these 5x's cancel out, and on the right side, these 5x's cancel out. Leave me with negative 4 is equal to 3. A similar situation to this right here. Thus, in order to get no solution, the x's on both sides of the equation have to match. Our answer is C. And I'll see you sometime. Guess what time it is? You guessed it, it's practice time. Woo! Wow! Who knew? So, questions 5 and 6. You now have 4 minutes to accomplish these 2 problems.
Welcome back. Okay, we're on to level 4. I have 4x plus 1 equals a negative ax minus 4. In the equation shown above, a is a constant. Which of the following values of a result in an equation with exactly one solution? We saw in previous examples that to be a no solution, my value in front of my variable, in this case x, must be the same number. So to be exactly one solution, I must have a different number in front of both my x's. So I see here I have just a negative a. Well, I only have a couple options. I have 4, negative 4, neither of them, or both. So if I plug in, I find which one will get me a different number in front of that x, I can find my answer. So if I plug in 4 into my negative a, I have now negative 4x. So that is a different number because on this side I'm a positive 4. We know this one checks out. Now we have to check this one and see if it also gets us a different number in front. So I have a negative 4 going in, so I have a negative 4. And we know a negative times a negative gets us a positive. So now this becomes a positive 4. I have a positive 4 on this side, so because they're the same number, that would get us a no solution, so he does not check out. My other two are either neither of these or both of these. I can't be neither because I have the first one already works. And I can't be both because this one didn't work. So my final answer is A. Okay, now on to number 8. We have 4 times the quantity 80 plus n equal to 3k times n. In the equation above, k is a constant. For what value of k are there no solutions to my equation? So I'm looking for getting no solutions. So I'm going to copy my problem. I see a number outside my parenthesis. Just like in previous examples, I want to distribute through. And to do that, we're going to do some multiplication. So I have 4 times 80. I know 4 times 8 is 32. Anything that has a 0 still will end as 0. So 4 times 80 is 320. And 4 times n is a positive for n. I have an n sitting on the right side of my parentheses on this side. Just like with the 4, I can distribute it through. So I have 3k times n. Well, I just have multiple variables. Whenever I have multiple variables, they all can just stand next to each other. So I have 3kn. Now we're looking to get this to no solutions. We've seen in previous examples to be a no solution, I need the number in front of both my variables to be the exact same. But we know k is going to be some constant. So I need to find out what value of k I need to plug in to make it 4. So now I no longer care about this 320. I only care about when these two are the same. So now I need to get my k by himself. So I have 3k. We know that this is being attached by multiplication. So I undo multiplication by division. What I do to one side, I do to the other. My 3 and 3 cancel out. I'm left with k equal to 4 over 3. Or I could say approximately 1.3 repeating. Either answer will get you full points. Okay, we have just finished all the examples for level 4. You now have 5 minutes to try your 2 practice problems, number 7 and number 8.
Example number 9. We have two fractions equal to each other, yet we still have to figure out what m equals. We are going to use a technique called cross multiplication on this one. That is where you find the product of diagonal parts of your fraction. So we are going to take m times 4 and 5 times m plus 6. Now this m plus 6 is all one quantity, so when we write it, we need to make sure that it is in parentheses. Let's go ahead and write it. I have 4 times m, which most of us know to be, good, 4m. On the other side, we put 5 times the quantity m plus 6. This is the part that needs to be in parentheses. Now, the most common mistake when doing a cross multiplication problem is that students will cross multiply, but they'll create a fraction. We do not want a fraction, we want another equation. Make sure you say that this product is equal to this product. That being said, we're going to start simplifying just like we have before. I have a 5 outside of these parentheses. That instantly caught my attention, so I'm going to distribute 5 times m and 5 times 6. Let's copy our problem now. 4m is equal to 5m plus 6 times 5, 5, 10, 15, 20, 25, 30. All right, now we have m's on both sides. We want to solve for m. I want to move this m onto this side so that all of my m's start together and all of my numbers are on their own side. I'm going to get rid of 5m by doing the opposite. Right now it is being added to 30. So my opposite of adding 5m is subtracting 5m this time. (4m) take away 5m, well, 4 minus 4 is 0, so 4 minus 5 must be a negative value. I get negative 1m is equal to, these canceled out, leaving me with 30 on the right side. One more thing. M is almost by itself. However, we have a negative 1 next to it. Thus, we have negative 1 multiplying to m. We need to divide both sides by negative 1 to get m alone. Divide by negative 1 on both sides. And we get a final answer of m being 30 divided by 1 is 30. And a positive number divided by a negative number is a negative. We get that m must be negative 30. Welcome back, ladies and gentlemen, to the final problem that we are going to be doing on level 5 and the final problem on your packet. This looks like a doozy. This is a big, ugly looking problem. But, as with most things in math, if you take it one step at a time, it's not so bad. So, I've gone ahead and taken the liberty of copying the problem. We are going to try to make it look more reasonable, simplify it some. I'm going to take my numerators and try to condense them down into something that we can work with. On my left side, I'm going to start simplifying. I have a 5 that needs to be distributed to this k plus 2 as it is outside of the parentheses. Let's start by doing that. 5 times k, and then 5 times 2. Well, 5 times k is 5k. Whereas 5 times a positive 2 is a positive 10. Because we distributed, we don't need to keep our parentheses. However, I should copy whatever is left outside of the parentheses, which is a negative 7 in this case. This is over 6. On my right side, I have a 13 minus 4 minus k. The most common mistake is that students will try to distribute this 13 in here. However, there's a minus sign in the middle, so we're not going to do that. What we will do is 13 minus each of these things. 13 minus 4 is, well, 9. We're also subtracting a negative k. If we subtract a negative k, what we have is minus negative k. What do these double negatives become? Very good. These two negatives become a positive. So I'm going to erase these and put a plus sign there. My denominator was 9, so I'll keep it as 9. Already, this is starting to look a little bit better. On my left side, I have 5k plus 10 minus 7. I notice these two terms can be combined. They are like terms. Neither of them have a variable. So, 10 minus 7 gives me 3. I will copy my problem. 5k plus our newly found 3 over 6 equals 9 plus k over 9. Now, I have two fractions separated by an equal sign. This tells me I can do what we used before. What was it called? Yes, I'm so glad you remembered. It is cross multiplication. We're going to cross multiply these and these. I'm going to move over here for room, but I'm multiplying 5k plus 3 times 9, which I like to put the single number by itself first. 9 times 5k plus 3 is equal to, not a fraction, but equal to our other product. 6 times 9 plus k. Now that we have them set up, our fractions are gone. This is even looking better than it did before. Let's distribute. Let's keep going. 9 times 5k. 9 times 3. Well, 9 times 5, doing my 5 tables, whatever. 9 times 5 is 45. Keep our k. Then we have a positive 3 times 9. 9 times 3 is 27. So I get positive 27. Here's my left side after distributing. Let's move to the right side. I'm going to distribute here as well because I also have parentheses on this side. 6 times 9, that might be a little tricky, but using your multiplication tables, we should get 54 plus 6 times k, which is, easy enough, 6k. We're really boiling this down now. We're on the last few steps. We have some k's and some numbers that we want to kind of separate. So I'm going to work on getting my k's on the left side and my constants or my numbers on the right side. I'm going to handle my k's first. I want to move 6k onto this side. The way that we move numbers is by doing the opposite, and the opposite of adding 6k is to subtract 6k. We will subtract 6k both times, or on both sides. These cancel out, leaving us with 45 minus 6, 39k, plus 27, all I did was copy this down, is equal to 54. If at any point in the video I'm moving too quickly, again, talk to your teacher about looking in the video and rewinding, whatever you need to do so you can get all of these steps. Moving on. I have all of my k's on my left side. I want to get all of my constants or my numbers onto the other side of the equation, away from k. So I want to move my positive 27 onto the other side with a big fat negative 27. What we do to one side, we do to the other. It's fat. So my 27s will cancel out, leave me with 39k on the left. On the right side, we have to do 54 take away 27. Let's do some borrowing type math, shall we? We cannot take away 7 from 4, so I'm going to borrow from my 5 neighbor, turn it into a 4, bring my 1 up front, and now I have 14 minus 7. 14 minus 7 I can do. That one is 7. Here we have 4 minus 2, leaving me with 2. 54 take away 27 is 27. Final step. Actually, not the final step. We'll talk about this. We need to get k by itself. And this seems like it should be the last thing to do. 39 is multiplying the k, so we know that we need to divide by 39. That is the opposite of multiplication. What I do to one side, I do to the other. These will cancel out, leaving me with k equals 27 over 39. I run through my choices and I see that's not one of my options. So I'm going to need to simplify this fraction or reduce it. I need to find a number that both the numerator and denominator can be divided by. So I can run through and think about what are my factors of 27. What goes into 27? Well, I know that 1 goes into 27, 2 does not, 3 does, and 3 times what makes 27? 3 times 9 makes 27. So 9 must be a factor. And 1 times what makes 27? 1 times 27. These are the only 4 things that could possibly multiply to 27. So I need to see if 39 is divisible by any of these 4 numbers. Well, everything is divisible by 1, but it doesn't make it any smaller. So 1 is a bad time. Let's take a look at 3. Can 39 be divided by 3? Oh, here's room. Yep, right here. We're going to try to divide 39 by 3. 3 goes into 3 one time. 3 times 1 is 3. We subtract these 2, giving us 0. Bring down our 9. Hopefully we remembered long division. 3 goes into 9 3 times. 3 times 3 is 9. 9 minus 9 is 0. That leaves us no remainder. That means 3 does go into 39 because it left us with no remainder. So I can divide the top and the bottom by 3. 27 divided by 3, I know is 9 from my times tables. And 39 divided by 3, we just figured out was 13. Our quotient was 13. So my new answer is 9 over 13. And looking at option B, that perfectly matches. We've just finished the last example, leaving you with just the practice to finish out this module. You now have 5 minutes to finish these 3 problems. Get cracking, eggs.